Hello there, gentle souls. Welcome to Conscious Frequency, where we explore the universe's quietest secrets and the whispers of consciousness. Tonight, we invite you to drift into a realm of wonder. We're going to gently unravel the profound, often poetic, nature of quantum physics, not as a rigid science, but as a canvas of possibility. Imagine photons as tiny dancers, atoms as resonant bells, and the universe itself as a symphony of interconnected vibrations. We'll explore concepts that challenge our everyday perception, inviting a sense of awe and deep contemplation. It's a peek behind the curtain into the very fabric of what is. As you settle in, perhaps with a warm drink or wrapped in a cozy blanket, take a moment to notice the light around you. What colors do you perceive? Where is your focus drifting? Share your immediate surroundings or a feeling you're experiencing in the comments below. We're all sharing this space, this moment together. If these explorations resonate with your inner world, consider joining our community. A gentle tap on the subscribe button ensures you won't miss our future journeys into the profound. Each subscription is a quiet affirmation that you're seeking deeper understanding and peaceful contemplation. Our journey tonight is a slow, deliberate unfolding. We'll begin with the very essence of light, moving through the strange dance of particles, the enigma of entanglement, and the fundamental nature of reality. Allow your breath to deepen, your thoughts to soften, and your awareness to expand. Let the soft light guide you. Our journey begins at the very source of illumination, the fundamental particle of light itself. Let's tune into its subtle song. It's fascinating to think about light, isn't it? We often imagine it as a simple beam, a straight line cutting through the darkness. But light, it turns out, is a bit more elusive. It's like a whispered secret, simultaneously of wave and of particle. Imagine it not as a solid thing, but as a delicate ripple spreading through the very fabric of existence, a gentle undulation in the cosmic ocean. Yet, at the same time, it's also made of these discrete packets of energy, like tiny energetic whispers, each one a distinct little pulse. This duality, this gentle nudge away from our everyday understanding, is the first hint that there's more going on than meets the eye. And these little packets, these energetic whispers, we call them photons. Each photon carries a specific amount of energy, and that energy is directly tied to its frequency. Think of them like musical notes, each with its own unique pitch, its own subtle vibration. Some are low and resonant, others high and piercing. This color we perceive, the vibrant hues that paint our world, is simply the frequency of these energetic whispers. A deep red is a slower, more drawn-out note, while a brilliant blue is a faster, more insistent one. They're all part of the grand, silent composition of light, a symphony playing out in every moment. And then there's the speed of light. It's this incredible, unwavering cosmic constant. It's the universal messenger, the silent, constant rhythm around which everything else in the universe seems to dance. No matter what, it travels at the same, unyielding pace, connecting all points in space-time. It's like a cosmic metronome, ticking away, a fundamental pillar that holds our reality together. It's a speed that's so fast, it's almost beyond our comprehension, a testament to the sheer elegance of the universe's design. But what happens when these light particles aren't just passive observers, but active participants in a much stranger, interconnected dance? When a photon encounters something, anything, it's not just a passing glance. There's an interaction, a gentle touch, a subtle exchange of energy. It can be absorbed, vanishing into the object, giving it warmth or energy. It can be reflected, bouncing back like a tiny, playful echo, allowing us to see the world around us. Or it can be transmitted, passing right through, like a ghost slipping through a wall. This dance of absorption, reflection, and transmission is what paints our world with color and form, giving everything its unique texture and appearance. It's like a silent symphony where each instrument, the photons, plays its part. Some notes are absorbed, creating shadows, the absence of brilliance. Others bounce back, creating the vibrant hues we see, the very essence of color. And the speed of the conductor's baton, the unwavering tempo of this cosmic orchestra, is the unyielding speed of light. But what happens when these light particles aren't just passive observers, but active participants in a much stranger, interconnected dance? Now, let's venture into the heart of quantum mechanics, where certainty begins to soften, like mist at dawn. It's here, in the realm of the impossibly small, that we encounter a rather peculiar whisper, this uncertainty principle. Imagine trying to catch a firefly on a summer night. You see its little light blinking, a fleeting spark. You know where it is in that instant, but if you try to also know how fast it's moving, how quickly it's darting away, your very attempt to measure its speed might nudge it, might change its trajectory. Werner Heisenberg, a brilliant mind, realized that for subatomic particles, this isn't just a practical difficulty, it's a fundamental law of nature. You simply cannot know both the precise position and the exact momentum of a particle simultaneously. The more accurately you pin down one, the more the other dissolves into a hazy blur. It's like trying to grasp a wisp of smoke. The very act of reaching for it, of trying to measure its density or its flow distorts it, changes it. And this dance of uncertainty is intimately tied to that curious idea we touched upon before, the S-wave particle duality. Remember how light, and indeed all matter, can behave like both a wave and a particle? Well, it turns out ours active observation plays a profound role in which face it shows us. When we design an experiment to pinpoint a photon's exact location, to say, it is here, it obliges behaving like a tiny, definite particle. But if we simply let it travel, if we don't try to trap it in a specific point, it unfurls like a wave, spreading out, existing in many places at once. It's as if our gaze, our intent to know, gently nudges it, coaxing it to choose a form. Our looking changes its very nature. So, instead of neat little dots with defined locations, we find these particles existing as probability clouds. Think of a gentle fog settling over a meadow at twilight. Within that mist, there's a higher chance of finding a dewdrop in the denser patches, but it could be anywhere within the swirling vapor. Particles aren't precisely here or there, they are more like a shimmering possibility, a spectrum of likelihoods. The denser the fog, the more probable it is that our particle friend is lounging in that particular patch of space. This leads us to the fascinating observer effect in quantum mechanics. It's not just about what we measure, but the very fact that we are measuring. The act of looking, of probing, of trying to understand the smallest components of our universe, fundamentally alters the system we're observing. It's as if the universe, at its most intimate level, holds its breath when we try to get a closer look. It's like trying to gently touch a butterfly's wing. The lightest brush can send it fluttering away, changing its flight path forever. Think of a perfectly still pond, reflecting the sky like a polished mirror. If you want to know exactly where a ripple is, the precise point where its surface is disturbed, you must, by definition, disturb the water. The more accurately you try to pinpoint its location, the more you change the ripple's form, its speed, its very essence. You can't measure its stillness and its motion at the same time without altering one or the other. This inherent fuzziness, this dance of probability and observation, hints at connections far deeper than mere interaction, connections that transcend space itself. And that's where our journey will gently lead us next. Does this idea of inherent uncertainty resonate with any feelings or experiences in your life? Prepare for a concept that bends the very fabric of connection, quantum entanglement, where particles share a single destiny. Imagine, if you will, two tiny dancers, born from the same cosmic ballet. They twirl and spin, utterly inseparable, even when the music carries them to opposite ends of the universe. This is the essence of quantum entanglement. It's a peculiar and profound linkage where two or more particles become so deeply intertwined that they essentially share the same fate. They cease to be individual entities and instead behave as a single, unified whole, no matter the unfathomable gulfs of space that might stretch between them. It's as if the universe, in its infinite wisdom, decided to weave a single thread through two impossibly distant points. Now, this is where things get truly wondrous, and perhaps a little bit dizzying. Einstein himself, a man who wrestled with the very nature of reality, famously described this phenomenon as spooky action at a distance. And it is, isn't it? Because when you observe or measure a property of one entangled particle, say its spin, its partner, light years away, instantly reflects that measurement. There's no delay, no signal traveling across the void. It's as if you flipped two coins simultaneously, and you knew with absolute certainty that if one landed heads, the other had to be tails, Even if one coin was here on Earth, basking in the sun, and the other was on Mars, bathed in its crimson dust. Let's try to grasp this with a bit more clarity, using the language of quantum physics itself. Consider the property of spin. Think of it like a tiny internal compass needle for a particle, pointing either up or down. If two electrons are entangled in terms of their spin, and you measure one and find it spinning up, you immediately know, without any further observation, that its entangled partner, no matter how far away, is spinning down. There's no message sent, no whisper carried on the solar winds. It's a shared inherent state, a preordained harmony that exists between them from the moment of their entanglement. The implications of this are staggering, truly. Entanglement challenges are most deeply ingrained. Everyday notions of how the world works, our concepts of locality, the idea that things can only influence their immediate surroundings, and causality, the sequential chain of cause and effect. It suggests that the universe isn't just a collection of separate objects interacting locally, but rather a deeply interconnected web, a tapestry woven with threads of non-local influence that bind even the most distant points. It hints at a reality far more fluid and unified than our senses might initially perceive. Think of it this way, a gentle analogy to help paint the picture. Imagine you have two identical gloves, perhaps knitted from the finest wool, and you send one across a vast, shimmering ocean. You keep the other. Now, if you look at the glove in your hand and see it's a left glove, you instantly know, with absolute certainty, that the glove on the other side of that ocean, still unseen, must be of right glove. Entanglement is like this, but far deeper, far more fundamental. It's not just about knowing a corresponding property, it's about a shared quantum identity, a unified existence that transcends physical separation. But what if this interconnectedness extends beyond mere particles, influencing the very fabric of space and time itself? Let us now imagine the very stage upon which all quantum events play out, space-time, not as a smooth sheet, but as a dynamic frothy sea. For so long we've pictured space-time as this grand, unwavering backdrop, a kind of cosmic stage curtain against which the universe performs its grand play. Einstein, with his beautiful general relativity, showed us it's far more than that. He revealed space-time as a unified fabric, woven from space and time itself, a fabric that can bend and warp, that can ripple and stretch. It's this very fabric that mass and energy dance upon, dictating the graceful waltz of gravity, guiding the planets in their celestial ballet. It's not a static void, but a living, breathing entity, the very canvas that dictates motion. But what happens when we zoom in, impossibly close, to the very smallest scales imaginable? Think smaller than an atom, smaller than a proton, down to the almost mythical Planck length. Here, the smooth, elegant fabric of space-time, as described by Einstein, is thought to dissolve into something far more chaotic. It's theorized to become a churning, effervescent quantum foam. Imagine the very essence of reality at this minuscule level, not as a solid structure, but as a restless, energetic void, a constant, seething effervescence. And what is this foam made of? It's populated by what we call virtual particles. These aren't the stable, everyday particles we're used to, like electrons or quarks. Instead, they are fleeting, ephemeral fluctuations in energy. They pop into existence like tiny, momentary sparks, as pairs of particles and their antiparticles, and then, just as quickly, they annihilate each other, vanishing back into the energetic ether. They are the briefest of whispers, the most ephemeral of dreams, the fleeting bubbles in this cosmic foam. This constant, frenetic activity in what we perceive as empty space suggests something profound. It hints that even the vacuum, the seemingly barren expanse between stars and atoms, isn't truly empty at all. It's teeming with potential energy, a latent dynamism that's always there, always bubbling. This vacuum energy is like the silent hum of the universe, a fundamental liveliness that underpins all of existence. It's a bit like looking at the surface of a deep, dark ocean from a great distance. From afar, it appears smooth, serene, almost glassy. But if you were to plunge beneath that surface, or even just get very, very close, you'd see it's anything but still. It's a churning mass of tiny waves, of effervescent bubbles constantly forming and bursting, of invisible currents pulling and pushing. This is the quantum foam. The seemingly empty vacuum is alive with fleeting activity, a vibrant, energetic dance happening at the very foundation of reality. This fundamental dynamism, this inherent liveliness of the vacuum, raises a question that tickles at the edges of our understanding. Could consciousness itself be an emergent property of this quantum dance? How does the idea of a living vacuum feel to you? Here's where our journey turns inward, exploring the profound role of consciousness in shaping what we perceive as reality. The quantum world, it's this incredibly strange and beautiful place, a realm of probabilities and potentials. And one of the most mind-bending puzzles that scientists grapple with is what's called the measurement problem. It's this question of when, exactly, does a quantum system, existing in a hazy cloud of possibilities, suddenly decide to settle into one definite state? Think of an electron, for instance. Before we look, it's not just here or there, but somehow both and neither, a delicate superposition of states. But the moment we try to pin it down, to measure it, it's as if it snaps into focus, choosing a single location. The answer, it seems, often hinges on the very act of observation or measurement. It's like a shy dancer, only revealing its final pose when the spotlight hits. And this is where consciousness, our own awareness, begins to weave itself into the fabric of this quantum dance. Some fascinating interpretations, pushing the boundaries of our understanding, suggest that it might be conscious awareness itself that acts as the catalyst, the gentle nudge that prompts these quantum possibilities to collapse into a single, concrete reality. Our attention, this incredibly subtle yet powerful force within us, seems to have the ability to solidify the probabilistic, to take that shimmering haze of what could be, and make it what is, at least for our experience. It's a quiet kind of power, isn't it? Now it's important to gently distinguish between this observer effect and the deeper implications of consciousness. Yes, any interaction, any physical measurement can cause a quantum system to change, to collapse. A photon bouncing off an electron, for example, will inevitably alter its state. But the unique role of consciousness as a potential collapse factor is where things get truly philosophical, a topic of deep, ongoing debate within both science and contemplative thought. It's this idea that our inner world, our subjective experience of being aware, might actually have a tangible impact on the external, physical realm. It's like discovering your thoughts have a subtle, invisible hand in sculpting the world around you. And this leads us to the very essence of our subjective experience of reality. It's our consciousness that acts as the ultimate filter, the interpreter that takes these dizzying quantum probabilities and weaves them into the coherent, predictable, and deeply personal reality we inhabit every single moment. It's the gentle hand that brings a sense of order, of narrative, to the underlying quantum chaos. Imagine the universe as an orchestra tuning up, a cacophony of potential notes and rhythms. Your consciousness is the conductor, listening intently, selecting specific melodies, and bringing them forth into a harmonious song that you can perceive and understand. Think of it like this: imagine a vast, uncharted map of potential paths, stretching out in every direction. Your consciousness acts like a gentle spotlight, illuminating one path at a time, making that particular journey the reality you travel. The other paths, the ones not bathed in your focused awareness, they remain as possibilities, unseen, unexperienced by your concentrated attention. It's your inner gaze that defines the terrain you walk upon. If consciousness, in this quiet way, can influence the quantum realm, can ripple through the very probabilities that make up our existence, then it begs a profound question. What about the collective consciousness? What about the shared awareness of humanity and its potential to shape our shared reality? Let's delve into a concept that allows for multiple possibilities to coexist simultaneously, the elegant state of superposition. Imagine, if you will, a tiny, almost impossibly small particle. Not a solid little ball, but more like a whisper of potential. In the quantum realm, this whisper can be in many places at once. It's not that it's rapidly zipping between locations, but rather that its very existence is spread out, a delicate diffusion across space. It can possess multiple properties, like spin or energy, all at the same time. It's as if the universe hasn't quite decided which version of the particle to present to us yet, so it offers them all, a shimmering bouquet of what could be. This idea, This dance of simultaneous states is famously captured in the thought experiment of Schrödinger's cat. Picture a sealed box, a dark, quiet chamber. Inside a cat, a vial of poison, and a single radioactive atom. This atom has a 50-50 chance of decaying within an hour. If it decays, it triggers a mechanism that breaks the vial, releasing the poison and, well, ending the cat's life. Now, according to quantum mechanics, until we open that box and observe, that atom is in a superposition of both decayed and undecayed states. And because the cat's fate is inextricably linked to the atom, the cat, in this bizarre quantum logic, is considered both alive and dead until that moment of observation. It's a stark, yet profoundly poetic, illustration of how possibility can linger, a ghost of states yet to be resolved. This very principle, this ability for information to exist in multiple states at once, is the engine driving the revolution of quantum computing. Think of our everyday computers, which use bits that are either a 0 or a 1. Quantum computers use qubits, and thanks to superposition, a qubit can be a 0, 1, or most remarkably both 0 and 1 simultaneously. Imagine the computational power this unlocks. Instead of checking possibilities one by one, a quantum computer can explore a vast landscape of potential solutions all at once, like 1,000 explorers charting different paths through a dense forest at the same instant. It's about harnessing this multiplicity, this rich tapestry of coexisting states, to solve problems that are currently unimaginable. But what happens when we finally decide to peek? When we open that box or measure that particle, the magic of superposition gently dissolves. The system, which was a symphony of potential, collapses into a single, definite state. It's not that one state was always the correct one hidden from us. Instead, the outcome is inherently probabilistic. The wave function, that mathematical description of the particle's spread out existence, dictates the likelihood of finding it in any particular state. So, when we measure, the universe makes a choice, a selection from that spectrum of potentials, and the veil of superposition lifts, revealing just one facet of what was. It's a bit like a musician playing a grand chord on a piano. All the individual notes, the deep bass, the resonant middle tones, the bright high notes, they're all sounded simultaneously. Each note is distinct, yet together they create a richer, more complex, and utterly beautiful sound than any single note could achieve alone. Superposition is the quantum chord, a blend of multiple possibilities, a harmonious resonance of what could be, played out at once. This ability to exist in multiple states hints at a deeper interconnectedness, a resonance between seemingly separate entities. Let's explore a phenomenon that defies classical intuition: particles having the ability to pass through barriers, as if by gentle persuasion. Imagine, if you will, a tiny energetic particle, perhaps an electron bouncing against a wall. In our everyday world, if it doesn't have enough oomph, enough sheer force, it simply bounces back, defeated. But in the quantum realm, things are a little more fluid. Particles possess this astonishing ability called quantum tunneling. It's like a ghost, not quite solid, not quite there, finding a way to slip through a wall that should, by all rights, be utterly impenetrable. It's not about brute force, it's about a subtle, almost whispered invitation to pass. How does this happen? Well, it's rooted in the very nature of these tiny entities. They aren't just little solid balls, they're also waves of probability. Think of it like a ripple on a pond. Even when that ripple encounters an obstacle, like a small pebble, a tiny part of the ripple's energy, its wave function, can actually extend into that pebble. And if the pebble isn't too thick, if the wave is persistent enough, a little bit of that ripple can actually emerge on the other side. That's quantum tunneling in essence, a non-zero chance, a whisper of possibility, that a particle can penetrate a barrier, even if it lacks the classical energy to climb over it. This isn't just some abstract, theoretical curiosity confined to dusty textbooks. Quantum tunneling is the quiet engine behind some of the most profound processes in the universe. It's the very mechanism that allows the sun to keep shining, powering nuclear fusion within its fiery heart. Without tunneling, stars wouldn't ignite. It's also the magic behind scanning tunneling microscopes, incredible devices that let us see individual atoms, the very building blocks of reality, by detecting the faint tunneling currents between a sharp tip and a surface. Even within our own bodies, it plays a role, facilitating crucial steps in processes like DNA replication. It's the unseen force, the gentle nudge, that enables so much of what we experience as life. Now, the likelihood of this tunneling happening isn't uniform. It's deeply influenced by the nature of the barrier itself. Imagine trying to push through a sheer, granite cliff versus a thin veil of silk. The thicker and higher the barrier, the exponentially lower the probability of tunneling. It becomes incredibly difficult, like trying to whisper a secret across a vast, roaring canyon. But here's the truly wondrous part: it's never impossible. Even the most formidable barrier holds a minuscule, yet persistent, possibility for a quantum particle to find its way through. Think of it like a soft breeze trying to move through a dense forest. Classically, it should be completely blocked by the thick trunks and interwoven branches. But the quantum breeze, with its inherent wave, like nature, has a tiny, almost imperceptible chance of tunneling through the leaves and branches, emerging on the other side, carrying its subtle scent. It's a testament to the universe's inherent fluidity, its willingness to bend the rules. This ability to bypass obstacles, to slip through the seemingly solid, suggests a deeper interconnectedness, a resonance that might extend to how we perceive time itself. Now, let's gently question our most fundamental experience, the passage of time, and how the quantum realm might perceive it. In the world we typically inhabit, the one of solid objects and predictable paths, time feels like a river, a steady, unwavering current flowing from yesterday, through today and into tomorrow. It's a linear clockwork, ticking with dependable regularity. But when we dip our toes into the shimmering, uncertain waters of quantum mechanics, time begins to behave differently. It's not quite so straightforward, not so neatly contained. Here, time becomes intimately woven into the very fabric of us quantum states, the ethereal probabilities that describe particles before we even peek at them. Its passage is tied to the evolution of these states, and crucially, to the act of measurement itself. It's as if time in the quantum realm is less of a river and more of a dance, a subtle choreography of potential. And then there's that most profound of questions, the one whispered in the quiet moments: why does time only move forward? We experience this as the arrow of time. We remember the past but not the future. A dropped teacup shatters, but never spontaneously reassembles itself. Quantum mechanics offers some fascinating glimpses into this, particularly through the concept of entropy. Think of entropy as a measure of disorder, a tendency for things to spread out, to become less organized. As entropy increases, the universe tends towards a more probable, more disordered state. This relentless march towards greater disorder seems to be the engine driving time's forward momentum. Yet, the truly fundamental nature of this directionality, this gentle current guiding existence, remains one of the universe's most enduring and beautiful mysteries. It's like trying to grasp smoke. You feel its presence, but its essence eludes you. Now, let's consider another mind-bending idea: quantum entanglement. Imagine two particles, linked in such a way that they share a destiny, no matter how far apart they are. When you measure one, the other instantly reflects that state. Some theorists propose that this profound interconnectedness, this spooky action at a distance, might actually be a key to unlocking the secrets of time itself. It's even suggested that time might not be a fundamental building block of reality at all, but rather an emergent property. An illusion, perhaps, born from the intricate web of these quantum correlations, like the patterns that emerge from a kaleidoscope when you turn it. This leads us to the very edge of our understanding, to the realm of quantum gravity, and equations like the Wheeler-DeWitt equation. In some of these attempts to weave together gravity and quantum mechanics, time, well, it seems to disappear. It's as if, at the deepest, most fundamental level of reality, there is no time at all, a timeless universe. And our perception of time, the steady march we experience, is something that emerges from this timeless foundation, perhaps as a consequence of how we, as observers, interact with this quantum tapestry. It's a bit like waking up from a vivid dream, where the boundaries of time can feel so fluid and strange. Imagine a silent film reel unfurling before you. Each frame is a distinct moment, a snapshot of existence. In the classical view, we watch the reel unspool, one frame after another, in a perfectly linear sequence. But in the quantum perspective, it's as if all those frames, all those moments, exist simultaneously, and our consciousness, our act of observing, is like a spotlight, choosing which frame to focus on, which moment to illuminate, thereby creating this illusion of forward motion, of time flowing. This radical questioning of time, this idea that it might not be the solid, unwavering pillar we assume it to be, opens the door to considering the nature of reality itself. Is it fixed, or is it fluid, shaped by possibility? Let's shift our focus from the tiny, fleeting particles to the pervasive, underlying reality that gives rise to them, the quantum fields. Imagine, if you will, that the universe isn't so much a collection of separate little things, but rather a vast, interconnected ocean. And within this ocean, there are fundamental invisible currents, like the electromagnetic field or the Higgs field. These aren't just concepts, they're thought to be the very fabric of existence, permeating everything, everywhere, all at once. And what we perceive as particles, the electrons, the photons, the quarks, they're not separate entities at all. They're simply excitations, like tiny ripples or energetic hums within these fundamental fields. So, a photon, that little packet of light, is really just a localized ripple in the electromagnetic field, and an electron, that familiar building block of matter, is an excitation in the electron field. It's a breathtaking idea, isn't it? It suggests that all the diverse particles we know, all the fundamental forces, are just different expressions or as vibrations of a single, underlying energetic substance. It's like discovering that all the different melodies you hear are just variations played on the same infinite instrument. And this is where it gets truly wondrous. Even in what we might call empty space, these quantum fields are still present. They're not absent, they're just in a state of quietude, a subtle hum. But even in this stillness, they're not truly still. They're constantly fluctuating, interacting, giving rise to what scientists call virtual particles. These are fleeting, ephemeral creations that pop into existence for an instant and then vanish like tiny sparks in the cosmic dark. So, the vacuum, this supposed emptiness, is actually a vibrant, energetic medium, a restless sea of potential. The standard model of particle physics, this incredible framework that describes the fundamental particles and forces, is essentially a map of these quantum fields and their intricate interactions. It's a beautiful, complex tapestry woven from universal energies. Each particle, each force, is a thread in this grand design, a specific resonance within the larger fields. It's like looking at a detailed fresco, where every brushstroke, every hue, contributes to the magnificent, unified picture. Think of it like this: imagine a vast, calm lake. This lake represents a quantum field, the fundamental, pervasive reality. Now, when you toss a pebble into that lake, it creates ripples that spread outwards. Those ripples, those disturbances on the surface, are like the particles. The lake itself, the water, the depth, the underlying stillness, that's the field. And from this single, tranquil body of water, all the diverse patterns of ripples can emerge. If the universe is fundamentally made of these deeply interconnected, interacting fields, could there be a deeper, unifying field that connects absolutely everything? What feeling does the idea of a connected universe evoke for you? We now turn towards one of science's most profound aspirations, the search for a single, elegant description of all fundamental forces and particles. Think about the universe, this vast, shimmering tapestry. It's held together, or perhaps more accurately, it's shaped by a handful of fundamental forces. We have gravity, the gentle, insistent pull that keeps our feet on the ground, and the planets in their orbits. Then there's electromagnetism, the spark of lightning, the warmth of sunlight, the very currents that carry our thoughts through our nervous systems. And deep within the heart of atoms, we find the nuclear forces, the strong force, the glue that binds protons and neutrons together, and the weak force, responsible for certain types of radioactive decay. These four forces, each so distinct, so powerful in their own right, govern every single interaction, from the smallest subatomic dance to the grandest cosmic ballad. Yet, for a long time, they were described by entirely separate sets of rules, like different languages spoken in different corners of the same magnificent city. But science, in its relentless curiosity, has a way of finding connections, of weaving threads between seemingly disparate ideas. And we've already seen glimpses of this unity. A significant step was the unification of electromagnetism and the weak nuclear force. At incredibly high energies, the energies that might have pulsed through the universe in its very first moments, these two forces merge. They become one, a single, elegant entity called the electrowake force. It's like discovering that two different melodies, played on separate instruments, are actually variations of the same underlying theme, only revealed in their full harmony when the volume is turned up to 11. This success has fueled even grander ambitions. We have what are called grand unified theories, or GUTs. These are ambitious attempts to fold the electroweak force together with the strong nuclear force, suggesting that at even higher, more primordial energies, all three of these forces were one. And then there's string theory, a truly mind-bending idea. It proposes that the fundamental building blocks of our universe aren't point-like particles at all, but rather tiny, vibrating strings. Different vibrations of these strings, like the different notes on a cosmic guitar, give rise to all the different particles and forces we observe. And in its most complete forms, string theory even has the potential to include gravity, to weave it into this single, harmonious tapestry. The biggest challenge, the Everest of this quest, is incorporating gravity. Gravity, as we perceive it, is so different from the other quantum forces. It's a force of attraction, of curvature in space-time itself. Trying to describe gravity within the same quantum framework that describes the other forces has been like trying to fit a vast, flowing river into a delicate, crystalline structure. Theories like loop quantum gravity and, of course, string theory offer different frameworks, different mathematical languages, to try and describe this quantum dance of gravity, seeking a cosmic harmony that embraces all the fundamental interactions. Imagine a magnificent orchestra. We've learned to understand the strings and brass section playing together beautifully, their melodies intertwining with grace. Now we seek a single conductor, a singular score, that can encompass the entire symphony, from the subtlest woodwind whisper to the deepest, resonating percussion. This pursuit of unity hints at a deeper interconnectedness, not just between forces, but perhaps between the very essence of matter and consciousness. What does the idea of a single, unifying principle for the universe evoke for you? Let us return to the fundamental building blocks, the particles themselves, and observe their intricate, energetic ballet. These tiny dancers, the very essence of everything we touch and see, aren't all cut from the same cosmic cloth. They fall into two grand families, like the two sides of a beautifully balanced coin. We have the fermions, the solid, dependable architects of matter. Think of electrons buzzing around an atom's nucleus, or the quarks nestled within protons and neutrons. They're the ones who build the structures, the very fabric of our physical reality. And then there are the bosons. These are the messengers, the carriers of forces, the invisible threads that weave interactions together. Photons, the packets of light that paint our world, are bosons. The Higgs boson, that elusive particle that gives mass to everything else, is also a boson. They're the ones who orchestrate the interactions, the energetic whispers that connect everything. Now, these Fermion dancers, they have a peculiar rule they must follow, a principle that seems almost like a cosmic etiquette. It's called the Pauli exclusion principle. Imagine a perfectly arranged garden, where each flower has its own designated spot, its own unique quantum state. This principle dictates that no two identical fermions can occupy the exact same quantum state at the same time. It's like a cosmic rule saying, one dancer per spotlight. This is why electrons, those tiny energetic fermions, don't all cram into the same energy level around an atom's nucleus. Instead, they fill up the available shells, creating the distinct atomic structures that give each element its unique personality, its chemical signature. Without this principle, atoms would collapse, and the ordered, diverse universe we know would simply dissolve into a formless haze. It's a beautiful testament to how strict rules can, paradoxically, create incredible complexity and order from what could otherwise be utter chaos. But the dance doesn't stop there. The forces that bind and repel, that shape our universe, they aren't transmitted through direct, solid contact. Instead, they're like secret exchanges, passed between particles through the fleeting existence of virtual particles. These aren't particles you can easily catch or measure in the same way as their more stable cousins. They pop into existence, mediate an interaction, and then vanish back into the quantum foam, like a whispered secret past in a crowded room. For instance, the familiar force of electromagnetism, the force that holds your atoms together and makes light shine, is mediated by the exchange of virtual photons. It's a constant, invisible conversation happening at the most fundamental level. And when we delve even deeper into the heart of the atom, we find the strong nuclear force, the glue that holds protons and neutrons together in the nucleus. This force is described by quantum chromodynamics, or QCD, and it's mediated by particles called gluons. These gluons are the ultimate enforcers of this incredibly powerful force. They bind quarks together so tightly that quarks are never seen alone. They're like mischievous children who can only be found playing together in groups, forming composite particles like protons and neutrons. Try to pull them apart, and the force only gets stronger, like stretching a rubber band until it snaps back with even more intensity. It's a force so potent that it keeps the very core of matter from flying apart. You can almost picture it, can't you? Imagine a grand, infinite ballroom bathed in a soft, ethereal light. The fermions are the meticulously arranged dancers, each occupying their own unique space, their own rhythm, their own particular pirouette. They are the substance, the presence. And then, the bosons are the other dancers, weaving between them, initiating the waltz, the tango, the subtle shifts in energy. They are the messengers, the conductors of this cosmic symphony, passing invisible cues, creating the intricate, dynamic patterns that make up the universe's grand choreography. It's a dance of rules and freedom, of order and constant motion, all happening beneath the surface of our everyday reality. This dance of particles, governed by such strict, yet elegant rules, really makes you wonder, doesn't it? How does such intricate, predictable order arise from the fundamental probabilities, the inherent fuzziness of the quantum realm? It's a question that whispers at the edges of our understanding, inviting us to look closer. Which fundamental particle do you find most fascinating, and why? We've touched on the quantum vacuum, but let's now immerse ourselves more deeply in its vibrant, energetic nature. It's a concept that truly invites us to reconsider our very notions of emptiness. You see, when we think of a vacuum, our minds often conjure up an image of a vast, silent, utterly empty expanse, like a perfectly clean, sterile room, devoid of anything at all. But in the realm of quantum mechanics, this classical idea of emptiness simply dissolves. The quantum vacuum isn't an absence of everything. Instead, it's a dynamic, seething sea of potential, a vibrant, energetic essence that hums with activity. It's a place where the very fabric of reality is in constant, subtle flux. And this ceaseless activity is powered by something truly remarkable: zero-point energy. Imagine, if you will, the very lowest possible state a system can exist in. We might think that at absolute zero temperature, where all motion ceases, a system would be completely still, utterly dormant. But the quantum world whispers a different story. Even at this ultimate stillness, quantum fields, the fundamental building blocks of everything, possess a minimum, irreducible energy. This is zero-point energy. It's like a gentle, underlying vibration that never truly goes away. And this inherent energy is the engine behind the constant, fleeting dance of virtual particles. These are particles that pop into existence, exist for an infinitesimal moment, and then vanish back into the energetic soup, like tiny, ephemeral sparks in the cosmic darkness. They are born from this zero-point energy, and then they return to it, a ceaseless ebb and flow. Now, you might be thinking, this sounds rather abstract. Can we actually see or measure this energetic vacuum? And the answer, wonderfully, is yes. One of the most elegant demonstrations of this vacuum energy is the Casimir effect. Imagine two perfectly flat, uncharged conductive plates, placed incredibly close together, perhaps only a fraction of a millimeter apart. In our classical view, nothing should happen. They're just two inert objects in empty space. But because of the quantum vacuum, something truly fascinating occurs. The quantum fields between the plates are restricted. They can't fluctuate in the same way as the fields outside. This difference in vacuum fluctuations creates a subtle pressure imbalance, a gentle push from the outside vacuum that's stronger than the pressure from that inside. And the result? These two uncharged plates, in what we perceive as empty space, are drawn towards each other, a tender embrace dictated by the invisible energy of the vacuum. It's a tangible whisper of the unseen forces at play. And this vacuum, this energetic sea, is also the very cradle of mass. It's through the Higgs field, which permeates this quantum vacuum like an invisible, all-encompassing ocean, that fundamental particles acquire their mass. Imagine a celebrity walking through a crowded room. They attract attention, they gather followers, they gain a certain weight in their interactions. Similarly, fundamental particles, as they move through the Higgs field, interact with it, and this interaction is what gives them their mass. Without this interaction, without the Higgs field's gentle embrace, particles would be as light as a feather, massless, and would forever travel at the speed of light, never slowing down, never forming the structures that make up our universe, including ourselves. It's like a perfectly clear, still pool of water. From a distance, it appears empty, serene, undisturbed. But if you lean in, if you look closely, you'll see tiny, fleeting ripples and bubbles, constantly appearing and disappearing, a silent, energetic ballad. This is the quantum vacuum, a dynamic, energetic essence, not an absence, but a profound presence. This inherent dynamism suggests that even empty space is a fundamental part of reality, potentially influencing how we perceive ourselves and our place within it. What does the concept of empty space being full of energy evoke for you? We touched upon entanglement earlier, but let's now explore its profound implications for interconnectedness in a deeper, more poetic sense. Imagine, if you will, two tiny particles, born together from the same cosmic breath, perhaps at the very dawn of time. They are entangled. This isn't just a passing acquaintance, it's a fundamental bond, a shared destiny woven into their very essence. They exist, in a way, as a single quantum entity, even when separated by unimaginable gulfs of space. If you were to gently nudge one, perhaps by observing its spin, to see if it's pointing up or down, the other particle, no matter how far away, would instantaneously adopt the opposite spin. It's as if they're whispering secrets across the universe faster than light itself could travel. This isn't a matter of them communicating in the way we understand it, but rather a reflection of a deeper, underlying reality where their states are intrinsically linked, a shared dance of probabilities. For a long time, this seemed too strange to be true. Albert Einstein famously called it spooky action at a distance. But then came Bell's theorem, a brilliant piece of theoretical work, and later, incredibly precise experiments. These experiments, like the ones conducted by Alain Aspect and many others, have consistently shown that the correlations between entangled particles are far stronger than any classical explanation, any theory of hidden instructions or pre-determined fates could ever account for. It's as if the universe itself is playing a game of chance, but with rules that defy our everyday intuition, validating the profound, almost magical, strangeness of quantum entanglement. The results are in this deep connection is real. And this isn't just a curious scientific footnote. Entanglement is the very engine of future technologies. It's the secret ingredient that makes quantum communication possible, allowing for secure information transfer that's fundamentally unhackable. It's the bedrock of quantum computing, promising to unlock computational power that could solve problems currently beyond our wildest dreams. It's a fundamental aspect of how the universe orchestrates complex interactions, a testament to its inherent potential for sophisticated, interconnected behavior. It's a resource, a fundamental property, that we're only just beginning to understand and harness. The philosophical implications are truly breathtaking. Entanglement whispers a radical idea that perhaps reality isn't made up of billions of separate, isolated objects, each going its own way. Instead, it suggests that everything might be part of a vast, interconnected tapestry, a single, unified field where separation is, in a sense, an illusion. Our very notions of individuality, of being distinct and apart, are challenged by this deep, interwoven nature of existence. It's a gentle nudge towards recognizing that we are not islands, but rather waves in a boundless ocean of being. Think of it like two dancers moving in perfect, synchronized harmony across a vast, dimly lit stage. Even when separated by miles, their pirouettes, their leaps, their very presence, seem to echo each other. Their movements aren't dictated by separate cues from a conductor, rather, they are bound by an invisible, shared rhythm, a single, unified melody that guides their every step, a silent understanding that transcends the physical space between them. If particles can be so intimately connected, what about larger systems? And could consciousness itself participate in such a grand entanglement? What is the idea of a connected universe, where everything influences everything else, mean to you? Let us now explore how these quantum mysteries subtly weave themselves into the very fabric of life, in ways we are only beginning to understand. Think about the quiet miracle of a leaf, bathed in sunlight. Photosynthesis, that fundamental process that fuels so much of our world, isn't just a simple chemical reaction. It's a dance of energy, a quantum ballet. Plants, in their infinite wisdom, seem to harness a quantum coherence. Imagine a tiny packet of light energy, a photon, arriving at a leaf. Instead of just picking the first path it sees, it explores all possible paths simultaneously, like a whisper traveling down every corridor of a grand sunlit hall, until it finds the most efficient route to the reaction center. It's a kind of quantum efficiency, ensuring not a single sunbeam is wasted, a beautiful, subtle optimization that classical physics can't quite explain. And then there are the tiny molecular machines within our cells, the enzymes. These biological catalysts are the unsung heroes of countless reactions. Some of them, it turns out, employ a trick called quantum tunneling. Imagine a tiny proton, a fundamental building block of matter, needing to move from one side of a small energy barrier to another to facilitate a reaction. Classically, it would need enough energy to climb over the barrier. But quantum mechanics allows it to do something far more magical. It can simply tunnel through the barrier, appearing on the other side as if by a gentle, unseen nudge. This quantum leap can make these enzymatic reactions happen astonishingly faster, a secret speed-up woven into the very biochemistry of life. Consider the astonishing feat of bird navigation. How do these tiny creatures, with no maps or compasses in the human sense, traverse continents with such unerring accuracy? One compelling hypothesis suggests they might use quantum entanglement in their eyes. Imagine specialized molecules in their retinas that become entangled, their fates linked no matter the distance. When these molecules interact with the Earth's magnetic field, this entanglement could allow them to sense the direction of the field, a subtle, almost poetic connection to the planet's invisible forces. It's as if their very vision is tuned to the quantum hum of the Earth. And even something as seemingly mundane as our sense of smell might be touched by quantum whispers. While we've long thought smell was about molecules fitting into receptor shapes like keys and locks, new research suggests it might involve detecting the quantum vibrations of those molecules. Instead of just shape, perhaps our noses are sensitive to the subtle, energetic hum of a molecule, a deeper, more resonant form of recognition. It's like discerning a melody by feeling the vibrations of the instrument, rather than just seeing its form. It's like a master artisan, working with incredibly delicate materials. They don't just use a hammer and chisel, they employ the finest brushes, the most precise tweezers, tools that allow for an exquisite level of detail and control. Quantum biology suggests that life itself has developed its own set of these incredibly sophisticated, almost magical quantum tools, allowing it to perform feats of engineering and efficiency that would be utterly impossible if we were bound solely by the rules of classical mechanics. These are not just interesting quirks, they are fundamental aspects of how life works. If life, in its most basic forms, can harness these subtle quantum effects, could our own consciousness, that most elusive and profound aspect of our being, be deeply intertwined with these fundamental quantum processes? Let us now weave together these threads, reflecting on what quantum mechanics tells us about the very essence of reality itself. It's a fascinating shift, isn't it? From the predictable ticking of a clock to the shimmering, uncertain dance of the quantum realm. Unlike the solid, dependable world of classical physics, where a thrown ball follows a perfectly predictable arc, or a planet traces an unswerving orbit, quantum mechanics whispers a different story. At its most fundamental level, reality seems to be probabilistic. Imagine, instead of a single, definite outcome, there's a whole spectrum of possibilities, like a cloud of potential waiting to be awakened. It's not that we don't know what's happening. It's that what's happening isn't fixed until it's observed. It's like a painter standing before a canvas, holding a palette of infinite colors, with the final masterpiece not yet decided. And then there's this idea of interconnectedness, of non-locality. Einstein famously called it spooky action at a distance. Quantum entanglement suggests that the universe isn't just a collection of separate, independent things, like marbles in a box. Instead, it's more like a deeply interwoven, connected web. When two particles are entangled, they become linked in such a profound way that measuring one instantaneously affects the other, no matter how vast the distance separating them. It's as if a whisper in one corner of the universe could echo, in that very same instant, in another, impossibly far away. It's a cosmic embrace, a silent, invisible thread binding all things. This leads us to the truly mind-bending role of the as-observer. In the quantum world, the act of looking, of measuring, seems to play a critical role in collapsing these possibilities into definite states. It's as if the universe holds its breath, waiting for our gaze to bring a specific reality into being. This hints at a participatory universe, where our consciousness isn't just a passive witness, but an active co-creator. We're not just looking at the world, in a very real sense. We're helping to shape it, to bring its potential into our experienced reality. It's a profound thought that our intention, might be a brushstroke on the canvas of existence. And what about the grand, complex phenomena we experience, the vibrant hues of a sunset, the intricate patterns of a snowflake, even our own consciousness? These might be what scientists call emergent properties. They aren't inherent in the individual quantum interactions, but rather arise from the collective behavior of vast numbers of these tiny, interconnected events. Think of it like a symphony. A single note, played by a single instrument, has its own beauty, but when thousands of notes, played by hundreds of instruments, harmonize and weave together, something entirely new, something breathtakingly complex and beautiful, emerges. It's the symphony of existence, born from the silent hum of the quantum. Think of a vast, shimmering tapestry. Each individual thread is a quantum particle or field, vibrating with its own unique potential. But it's the way these threads are woven together, their intricate interactions and subtle dependencies, that creates the rich, complex image of reality we perceive. We are part of that weaving, each of us a thread, contributing to the grand design. This participatory universe opens profound questions about our own role in co-creating reality, and how our inner states might resonate with this cosmic dance. We now venture into the most enigmatic territory, the potential connection between the quantum realm and the nature of consciousness itself. It's often called the problem of consciousness, isn't it? This deep, almost unbridgeable chasm between the firing of neurons, the dance of chemicals in our brains, and the daw's rich tapestry of subjective experience. How does the simple act of seeing the color red, or feeling the warmth of sunlight on your skin, or the bittersweet ache of a memory, emerge from mere physical processes? It's like trying to explain the melody of a symphony by only describing the vibrations of the strings. Quantum mechanics, with its inherent strangeness and its focus on the fundamental building blocks of reality, offers some truly mind-bending, though still very speculative, avenues to explore this profound mystery. One of the most intriguing, and certainly most debated, ideas comes from Sir Roger Penrose and Stuart Hameroff, with their orchestrated objective reduction, or OR theory. They propose that consciousness isn't just an emergent property of complex computation, but rather arises from quantum computations happening within tiny structures inside our neurons called microbulas. These aren't your everyday electrical signals. They're thought to be capable of maintaining quantum coherence, allowing for incredibly complex information processing. The theory suggests that consciousness itself might be linked to the moment these quantum states collapse or reduce in a way that's orchestrated by these biological processes. It's a vision of the brain as a quantum computer, humming with an awareness born from the very fabric of quantum reality. Now, the idea of quantum coherence, things like superposition, where a particle can be in multiple states at once, or entanglement, where particles are linked no matter the distance, persisting in the warm, wet, noisy environment of the brain is, to say the least, a challenge. Many scientists believe these delicate quantum states would decohere almost instantly, unable to survive the biological chaos. But proponents of theories like OR suggest that the brain might have evolved mechanisms to shield and utilize these quantum phenomena, allowing for a level of information processing and interconnectedness that classical physics simply can't account for. It's a whisper of possibility that the universe's most fundamental rules might be playing out within us, shaping our very awareness. And then there are the philosophical interpretations, the ones that gently nudge us to consider consciousness not just as something that emerges from matter, but as a fundamental aspect of reality itself. Perhaps consciousness isn't a product of the universe, but rather the universe is a product of consciousness, or at least they are deeply intertwined. In this view, our consciousness might be an inherent quality of the cosmos, a field of awareness that we, as biological beings, are uniquely tuned into. This perspective opens up the possibility that our consciousness could be interacting with quantum fields in ways we are only just beginning to imagine, a subtle but profound dance between the inner self and the outer universe. Imagine the brain as a complex radio receiver. While classical physics can beautifully describe the wires, the circuits, the transistors, the very architecture of the device, quantum mechanics might offer us the key to understanding how it actually tunes in to the subtle frequencies of awareness. It's not just about the hardware, it's about how that hardware resonates with the unseen broadcast of consciousness itself, the invisible symphony that plays out across the cosmos. If consciousness is so intimately linked with the quantum, what does this imply for our perception of dreams and altered states of awareness? Let us now softly drift into the realm of dreams, exploring how they might reflect the fluid, probabilistic nature of the quantum mind. When we sleep, it's like our inner world shifts gears entirely. The usual strict guard of the prefrontal cortex, that part of our brain that keeps us grounded in linear reality, it loosens its grip. And what emerges is this wonderfully chaotic, free, flowing dance of associations. It's as if the brain, no longer tethered to the demands of the waking world, becomes a more unconstrained quantum system, allowing thoughts and images to shimmer into existence without the usual logical scaffolding. It's a state where possibilities feel less like solid objects and more like shimmering waves, ready to coalesce into something unexpected. And that's precisely what we see in our dreams, isn't it? They're these incredible tapestries woven from threads that, in our waking lives, seem utterly disconnected. A childhood memory might suddenly intertwine with a fleeting thought from earlier that day, all set against a backdrop of impossible architecture. It's this associative nature, this willingness to connect the seemingly unrelated, that feels so profoundly quantum. It mirrors that strange, almost magical interconnectedness we find in quantum phenomena, like entanglement, where particles can influence each other instantaneously, regardless of distance. Dreams, in a way, are the subconscious mind's own form of entanglement, linking disparate pieces of our inner universe. The narratives that unfold in our dreams are rarely, if ever, strictly causal. There isn't always a clear, if this then that. Instead, the story flows, shifts, and morphs with a kind of symbolic fluidity. It's as if the subconscious is engaging in a unique form of probabilistic narrative generation. Instead of following a predetermined path, it's more like a cloud of potential realities, a spectrum of possibilities, that gently collapses into the dream experience we perceive. One moment you're flying, the next you're having a conversation with a talking teacup, and it all feels right in that moment. It's a beautiful, often surreal, unfolding of the mind's latent potentials. There's a growing sense that our subconscious mind might be operating on principles that resonate with quantum mechanics. Imagine the subconscious as this vast, dark ocean. During waking hours, we focus on the surface, the conscious mind, observing the waves and currents we can easily perceive. Dreams are like the deep currents, bringing up strange, beautiful, and sometimes unsettling forms from the depths, where possibilities are more fluid. It's hypothesized that this deeper processing might utilize quantum principles, allowing for novel connections, creative leaps, and profound insights that surface in dreams, often in ways that defy our waking logic. It's as if the subconscious is a quantum computer, running simulations of reality and meaning. This exploration of subjective experience, the deep dive into the dream state, leads us to consider the broader implications for how we perceive and interact with the world around us. What is a recurring image or feeling from your dreams that feels particularly profound? Let's gently revisit the role of the observer, not just as a passive viewer, but as an active participant in the quantum unfolding of reality. It's a curious dance, isn't it? This idea that the very act of looking, of measuring, can fundamentally alter what we're observing. In the quantum realm, it's as if reality itself holds its breath, waiting for our gaze. Before we measure a quantum system, it exists in a state of superposition, a shimmering cloud of possibilities, like a coin spinning in the air, neither heads nor tails, but both, and neither, all at once. But the moment we reach out, the moment we measure it, that cloud collapses. It's forced to choose, to settle into one definite state, one specific outcome. It's as if our attention is a gentle, yet decisive, hand that nudges the universe into being. Now, this notion of the observer itself is a fascinating rabbit hole. What exactly is an observer in this context? Is it any interaction, any bump or nudge that causes a quantum system to lose its delicate superposition? Or does it require something more? Perhaps a conscious observer, a mind attuned to the subtle vibrations of existence? Or could it be a complex measuring device, a sophisticated instrument designed to capture these fleeting moments? The truth is, this definition remains a point of intense debate, a philosophical inquiry that tickles the edges of our understanding. This leads us to some truly mind-bending ideas, like the participatory anthropic principle. It's a concept that suggests the universe's fundamental properties, all those constants and laws we've come to know, are precisely as they are, because they allow observers like us to exist. It implies a deep, almost inherent connection, a cosmic handshake between the universe and those who witness it. It's as if the cosmos, in its vast, silent wisdom, has arranged itself so that conscious beings can eventually arise and ponder its very nature. If observation in this quantum sense influences the states of reality, then it suggests something profound about our own role in the grand tapestry. Our attention, our awareness, our very presence, they might not be mere passive reception, but active contributions to the manifestation of the world we experience. We're not just spectators in a cosmic play, we might be as co-creators, gently shaping the unfolding narrative with every thought, every feeling, every conscious moment. Imagine a vast, unwritten symphony. The notes are all potential, a silent sea of possibilities waiting to be heard. Your act of listening, of paying attention, is like the conductor bringing specific melodies to life, shaping the performance that unfolds. The music wasn't truly there until you chose to listen to it. This active role, this subtle yet profound influence, suggests that our inner state, our intentions, might have subtle, yet profound, connections to the external world. How does the idea that you might be co-creating your reality feel to you? Does it spark a sense of wonder, or perhaps a touch of responsibility? Let us broaden our perspective, considering how coherence and entanglement might influence the universe on its grandest scales. Think back, if you will, to the very dawn of everything. The early universe, that incandescent infant, was a realm of astonishing uniformity. It was homogeneous and isotropic, a state of profound coherence. Imagine a perfectly smooth, unblemished canvas, stretching out in every direction. It's thought that the subtle, almost imperceptible quantum fluctuations during that explosive inflationary period were the very seeds, the faint whispers, that eventually grew into the grand cosmic structures we see today, the galaxies, the nebulae, the vast cosmic web. These tiny quantum ripples, amplified by the universe's initial expansion, became the blueprint for all that is. And then there's the tantalizing idea of cosmic entanglement. Some of the most forward-thinking theoretical models explore the possibility that distant regions of the universe, separated by unimaginable gulfs of space, might still be entangled. It's even whispered that the universe itself could be entangled with its own past, or perhaps its future states, suggesting a fabric of existence so deeply interwoven, so intricately connected, that it defies our everyday notions of separation. It's like finding out that two seemingly independent raindrops, falling on opposite sides of a vast ocean, are somehow still linked by an invisible, shimmering thread. This is where the quest for quantum gravity truly shines. Scientists are wrestling with theories that aim to bridge the seemingly irreconcilable worlds of quantum mechanics and general relativity. These are the ambitious attempts to explain the universe's very origins, its unfolding story, in moments where quantum effects reign supreme. They're trying to understand how the universe, in its infancy, was governed by these fundamental quantum rules, and how that delicate quantum dance ultimately shaped the cosmos into the breathtaking spectacle it is today. We can begin to see the universe not as a collection of separate objects, but as a single, vast, a quantum system. Every particle, every field, every ripple of space-time is fundamentally interconnected. They are all dancing to the same subtle, quantum rhythm, influenced by the same underlying laws. It's a truly holistic perspective, where everything is subtly nudging and influencing everything else, like a colossal, cosmic organism breathing in unison. Imagine a vast, cosmic symphony. The individual instruments, the stars, the planets, the dust clouds are like quantum particles. But the entire orchestra plays with a unified rhythm and harmony, a grand coherence that shapes the unfolding music of existence. It's not just individual notes, but the way they blend and resonate together, creating something far grander than the sum of its parts. This cosmic interconnectedness hints at a subtle resonance that might extend to our individual consciousness and its place within this grand design. Let us now explore the fundamental relationship between matter and energy, as understood through the lens of quantum mechanics. It's a dance, really, a profound and ancient waltz that underpins the very fabric of our existence. We often think of matter as solid, tangible, something we can hold, and energy as something more ethereal, like light or heat. But quantum mechanics, with its gentle whispers and surprising revelations, shows us they're not so separate after all. Think of Einstein's iconic equation, E equals mc dou. It's more than just a formula scribbled on a blackboard. It's a key unlocking a secret room, revealing that mass and energy are, in essence, two sides of the same shimmering coin. Mass is a concentrated form of energy, and energy, given the right conditions, can condense into matter. At the unimaginably small scale of particles, this equivalence isn't just a theoretical curiosity, it's the very way things work. It's how the universe breathes, exhales, and creates. Consider the humble atom, the building block of everything we see and touch. Within its delicate structure, electrons don't just orbit randomly, they reside in very specific energy levels. Imagine them as dancers on a staircase, each step a distinct energy state. To move from one step to another, an electron must either absorb a precise packet of energy, a photon, or emit one. This isn't a smooth, continuous glide, it's a sudden leap, a quantum jump. It's like the universe saying, you can only be here, or there, never in between. This quantized nature of energy exchange, this discrete hopping between levels, is a beautiful demonstration of how energy manifests in tangible, measurable ways within matter. And then there's the breathtaking spectacle of particle, antiparticle creation and annihilation. In the fiery crucible of high-energy events, like those in particle accelerators or the hearts of stars, pure energy can quite literally congeal into matter. Two particles, a particle and its antimatter twin, spring into existence from the void. Conversely, when a particle meets its antiparticle, they don't just bump into each other, they annihilate, dissolving back into pure energy, a flash of light. This is immanent in its most dramatic, most visceral form, a constant reminder that matter is just energy in a particular, very dense costume. Quantum field theory takes this understanding even deeper, painting a picture of reality not as a collection of tiny billiard balls, but as a vast, interconnected web of fields. Particles, in this view, are simply excitations within these underlying fields, like ripples on a cosmic pond. The energy of these excitations, the intensity of the ripple, is what we perceive as mass. So, the solidity of your hand, the weight of a mountain, the very resistance you feel when you touch something, it's all a manifestation of the energy woven into these fundamental fields. It's an intimate, unbreakable bond. Imagine a flowing river, its currents carrying an immense power, a constant motion. Let this flowing water represent energy, ever present, ever moving. Now, at certain points along this river, the water can swirl and eddy, forming miniature whirlpools, intricate patterns that seem almost solid, almost distinct. These eddies and whirlpools are like the particles of matter. They are not separate from the river, they are as born from its flow, temporary configurations of the water's own energy. The river's ceaseless movement, and the distinct forms of the whirlpools are intrinsically linked, two expressions of the same underlying substance, the same energetic reality. This deep unity of matter and energy hints at a universal resonance, a fundamental vibration that connects all things. What feeling does the equivalence of matter and energy evoke for you? Let us explore how information itself, a seemingly abstract concept, might be deeply rooted in the quantum fabric of reality. We often think of information as something we read, something written in books or stored on a hard drive. In our everyday, classical world, information is quite definite. It's like a light switch, either on or off, a 0 or a 1. But when we dip our toes into the quantum ocean, things get wonderfully fuzzy. Quantum systems don't deal with simple bits, they use qubits. And a qubit, my friends, can be a 0, a 1, or, and this is where the magic truly begins, it can be both 0 and 1 simultaneously, existing in a shimmering state of superposition. It's like holding a coin that's spinning in the air, not yet landed, but containing the potential for both heads and tails. This offers a richness, a depth to information that our classical minds can barely grasp. And then there's this utterly fascinating phenomenon called quantum entanglement. Imagine two particles, born from the same quantum event, forever linked, no matter how far apart they drift. If you measure a property of one, say its spin, and find it to be up, you instantly know the spin of its entangled partner is down, even if it's light years away. It's as if they share a secret, instantaneous whisper across the vast cosmic silence. This suggests that information isn't always neatly tucked away in one place. It hints at a universe where information might be woven into a vast, non-local network, a cosmic tapestry, where threads of data are intertwined in ways we're only beginning to comprehend. Some of the most mind-bending ideas in physics even suggest that our entire universe might be a kind of hologram. Not a hologram in the sense of a trick of light, but a projection of information encoded on a distant boundary, like a vast cosmic hard drive. If this is true, then the very reality we experience, the solid ground beneath our feet, the air we breathe, might ultimately be informational at its deepest, most fundamental level. It's a notion that makes you tilt your head, isn't it? That the universe itself is, in essence, a colossal, unfolding quantum computation. Indeed, some of the brightest minds in physics are starting to propose that information itself might be more fundamental than matter or energy. Think about that for a moment. Not the stuff we can touch and see, but the patterns, the relationships, the meaning. Perhaps the universe isn't built from tiny particles of matter, but from tiny packets of quantum information, interacting and evolving in a grand, cosmic dance. It's a perspective that shifts our understanding of existence, from a collection of physical objects to a vast, interconnected web of data, a living, breathing quantum algorithm. It's almost like imagining a colossal library, not of dusty tomes, but of quantum states. And the information isn't just contained within the words on the pages, but in the very arrangement of the books, their potential connections, how they might be read together, influencing each other across the shelves. The universe, in this light, is a living, quantum library, constantly writing and rewriting its own story, its own information. If information is so fundamental, so interwoven with the very fabric of existence, could our consciousness be a form of quantum information processing, shaping our experience of the world? What does the idea of the universe, being fundamentally informational, evoke for you? Let us now explore the intriguing possibility that consciousness itself might be a fundamental quantum field, permeating existence. It's a notion that feels both deeply familiar and utterly mind-bending, doesn't it? Like trying to grasp the scent of rain before the clouds even gather. We've spoken of quantum fields, those invisible, energetic tapestries that weave the very fabric of our universe, from the subtle hum of electromagnetism to the sturdy embrace of the strong nuclear force. Now, some thinkers, with a twinkle of curiosity in their eyes, wonder if consciousness isn't just something that emerges from complex arrangements of matter, but rather a foundational field in its own right. Imagine a universal field of consciousness, a subtle, pervasive presence that interacts with matter, with energy, and indeed, with the very dance of quantum processes. It's as if the universe itself has a quiet, inner knowing. If we consider consciousness as such a field, then our individual awareness, our unique stream of thoughts and feelings, could be seen as localized excitations, or perhaps gentle resonances within this grander, universal field. Think of it like tuning a radio. Our personal consciousness is a specific frequency, picked out from the vast broadcast of the cosmic field. And these localized resonances, these individual minds, would then interact, subtly influencing and being influenced by the quantum fields that make up the physical world around us. It's a beautiful thought that our inner world might be a ripple on an ocean of awareness. And this perspective opens up fascinating avenues for understanding things like of collective consciousness. If there's a universal field of awareness, then perhaps our shared experiences, those moments of collective intuition or uncanny synchronicity, aren't so much coincidences as they are echoes, or even harmonic convergences, within this unified field. It could be the framework that explains how minds can feel connected across vast distances, how empathy can bloom spontaneously, and how ancient wisdom seems to whisper through generations. It suggests a deep, unspoken kinship, a shared breath across all of existence. Philosophically, this view aligns beautifully with ancient wisdom traditions and certain strands of modern thought, like panpsychism or idealism. It suggests that consciousness isn't some late-stage byproduct of complex biological machinery, but rather a primary aspect of reality, woven into the very essence of being, from the smallest particle to the grandest galaxy. It's a universe that is not just alive, but aware in its deepest, most fundamental nature. It shifts our perspective from being isolated sparks to being integral threads in a magnificent, luminous tapestry. Imagine the ocean as the universal field of consciousness. Each wave is an individual mind, unique in its form and expression, its crests and troughs, its particular journey across the surface. Yet, each wave is fundamentally part of the same vast, interconnected ocean, drawing its substance from its depths and returning to it in time. The wave is distinct, but never truly separate from the water that makes it. This profound interconnectedness leads us to contemplate the nature of our individual identity within this grand cosmic tapestry. If consciousness were a universal field, how might that change your perception of your own identity? Let us now gently dissolve the perceived boundaries, exploring how quantum mechanics reveals the illusion of separation in our universe. It's a curious thought, isn't it? This feeling we have, this deep-seated sense of being distinct, of being separate from everything else. We see the world as a collection of individual things, each with its own hard edges. But the universe, when we peer into its deepest, most shimmering heart, whispers a different story. Quantum mechanics, with its subtle, almost whimsical nature, offers us profound clues. Consider for a moment quantum entanglement. It's like finding two coins, spun from the same breath, that are forever linked. No matter how far apart they drift across vast cosmic oceans, if one lands heads, the other instantly lands tails. There's no signal, no message sent through space. It's a non-local correlation, a deep, instantaneous connection that suggests these seemingly separate entities are, in fact, woven from the same cosmic thread, utterly intertwined. This challenges our very notion of isolation, doesn't it? It's as if the universe is winking at us, showing us that distance, in its most fundamental sense, is a bit of a mirage. And then there are the quantum fields. Imagine reality not as a scattering of tiny hard marbles, but as a vast, shimmering, all-pervading ocean. Everything we perceive as particles, the light, the matter, even the subtle energies that hum around us, are simply excitations, ripples, or patterns within this single, unified field. A particle isn't a lonely, isolated speck, it's a localized vibration, a dance within this boundless, underlying reality. It's like the difference between seeing a single drop of water and understanding that it's part of the immense, interconnected ocean. This perspective suggests that what appears distinct on the surface is, at its core, a manifestation of one unified, flowing existence. We're not just in the universe, we are, in a very real sense, of the universe, expressions of this fundamental field. It's also fascinating to consider our role as our observers. Often, it's our very act of looking, of measuring, that seems to solidify and define things, creating the distinctions we perceive. Before we observe, before we try to pin something down, systems can exist in a more fluid, interconnected state, a kind of quantum soup of possibilities. Our consciousness, our focused attention, acts like a gentle hand that shapes the formless into the familiar. It's like a fog that, when you try to grasp it, condenses into distinct droplets. But before that, It was just mist everywhere at once. So, the very act of defining something can, in a way, create its perceived separation. And what about our own sense of self? This feeling of being a singular, bounded individual, a distinct me in the world. Could this, too, be a beautiful construct of consciousness? A focal point of awareness that creates a perceived boundary, a kind of internal horizon, while at a much deeper, more subtle level, we are simply a part of this larger, interconnected whole. It's as if our consciousness is a tiny, luminous island in a vast, interconnected sea. We experience the island as our whole world, but the sea is always there beneath, around, and connecting us to every other island, every other wave. Imagine the ocean again. We see individual waves distinct and separate, each with its own crest and trough, its own unique shape. But they are all made of the same water, aren't they? They are all part of the same, immense ocean. Our sense of individual identity is like a wave, distinct on the surface, perhaps even beautifully unique, yet fundamentally connected to the vastness below, to the same water that makes up every other wave. We are all, in essence, expressions of the same cosmic ocean, if separation is indeed an illusion. What does this mean for our understanding of connection, of compassion, and our place in the grand, unfolding cosmos? As our journey nears its gentle conclusion, let us pause and embrace the profound sense of wonder that these quantum mysteries evoke. It's a curious thing, isn't it, how the very fabric of reality, when we look closely enough, whispers secrets that defy our everyday understanding. Quantum physics, in its quiet way, invites us to a profound acceptance of the unknown. It asks us to let go of the need for every single piece to fit neatly into a predictable puzzle. Imagine a vast, star-dusted sky, where some constellations shimmer with familiar patterns, and others remain elusive, their forms only hinted at by the faintest starlight. This acceptance, this gentle surrender to what we cannot precisely know or predict, is like a soft breath of humility, opening our minds to a deeper, more expansive truth. It's not about having all the answers, but about cherishing the questions themselves, allowing them to bloom like quiet flowers in the garden of our awareness. And in this embrace of the unknown, we discover a universe of breathtaking beauty. The intricate, often counter-intuitive workings of the quantum realm are not just abstract concepts, they are the threads of an incredibly rich tapestry, woven with an elegance that our everyday perceptions can barely grasp. Think of the way light can be both a wave, flowing like a gentle river, and a particle, a tiny, discrete spark, or how particles can be in multiple places at once, a phantom dance until observed. This complexity isn't chaotic, it's a symphony of interconnectedness, a testament to a universe far more profound and artfully designed than we might have initially imagined, a masterpiece painted with the subtlest of hues. This is where the true magic lies, in cultivating of childlike curiosity. The questions raised by quantum mechanics aren't meant to be definitive pronouncements, neatly boxed and filed away. Instead, they are gentle invitations, whispers urging us to continue exploring, to keep that spark of wonder alive. They are like ancient riddles, not designed to be solved, but to be contemplated, to be turned over and over in our minds like smooth, sea-worn stones. This ongoing quest, this lifelong exploration of the universe's quiet secrets, is what keeps our spirits vibrant and our minds open to the endless unfolding of existence. There's a certain poetry to science, you know. Quantum mechanics with its concepts of superposition, where possibilities exist in a shimmering haze of entanglement, where particles are linked across vast distances as if by invisible silken threads, and of uncertainty, the inherent fuzziness at the universe's deepest levels. It all speaks a language that resonates with the heart. It invites us to see the universe not just as a cold, mechanical clockwork, but as a living, breathing, evolving mystery, a poem written in the stardust. It's a reminder that beneath the surface of the mundane, there's a profound, almost musical order. Think of stargazing on a clear, silent night. The sheer vastness of it all, the twinkling lights stretching into infinity, inspires a deep sense of awe, a feeling of being both incredibly small and intimately connected. Quantum physics is like looking at the universe's most fundamental stars, the invisible atoms and their elusive particles. It reveals an even grander, more intricate celestial dance, a cosmic ballad that fills us with a deep, quiet wonder, a sense of profound belonging within this magnificent, mysterious cosmos. This profound sense of wonder is the perfect prelude to a moment of reflection and peaceful transition into rest or deeper contemplation. What is one word that captures your feeling of wonder after this exploration? As we gently draw our exploration to a close, let us consider our own place within this vast, interconnected quantum tapestry of being. It's a thought that can feel both humbling and exhilarating, isn't it? To realize that at our most fundamental level, we're not so much solid, separate things as we are vibrations. We're spun from the same cosmic threads as the distant nebulae, the shimmering light of 1,000 suns. Every atom within you, every tiny particle dancing in the void, is a participant in the grand quantum ballet. We are, quite literally, woven from the same fundamental fabric as the stars, a breathtaking realization that whispers of a deep, inherent kinship with all that is. And this intrinsic connection, this sharing of the same quantum foundation, suggests something truly profound, an interconnectedness that binds us all. If all matter, all energy, is fundamentally linked through unseen quantum fields, through the spooky, beautiful dance of entanglement, then it's not a stretch to imagine that all life, all existence, shares a deep, intrinsic unity. We're like ripples on the same boundless ocean, each unique, yet all part of the same watery expanse, influencing and reflecting each other in ways we're only beginning to comprehend. And what about our consciousness, this inner universe of thoughts, feelings and awareness? It's possible, even probable, that our consciousness is itself a manifestation of these subtle quantum processes. It acts as this exquisite focal point, this lens through which the universe experiences itself. It's our consciousness that gathers these quantum whispers, interprets the symphony of existence, and perhaps, in its very act of observation and intention, even helps to shape its unfolding. We are not passive observers, we are active participants in this grand, unfolding story. Understanding this fundamental quantum nature, this inherent unity, can bring such a profound sense of peace. It's like coming home to a truth that's always been there, waiting to be recognized. It fosters a gentle acceptance of ourselves and the universe, encouraging us to live in greater harmony, not just with the world around us, but with the very essence of our being. It's a reminder that the perceived boundaries between us are more like shimmering illusions, and the reality is a vast, loving embrace. Imagine yourself as a single, unique note within a grand cosmic symphony. You are distinct, a melody all your own, yet your note resonates with all other notes, contributing to the overall harmony and beauty of the entire composition. Without your unique sound, the symphony would be incomplete. This profound sense of unity, of belonging to something so vast and mysterious, is a fitting way to prepare for a gentle transition into deeper rest and peace. We have journeyed through the soft light of quantum mysteries, from the humble photon, that tiny spark of light, to the vastness of quantum fields like unseen oceans. We've explored uncertainty, the delightful dance of not quite knowing, entanglement, that strange, invisible thread connecting distant particles, superposition, where things can be in multiple states at once, like a coin spinning in the air, and the potential role of consciousness in shaping reality. Each concept, a gentle whisper from the universe's deepest secrets, a shimmering possibility. The quantum realm reminds us that reality is far more fluid, more interconnected, and infinitely more wondrous than our everyday perceptions might suggest. It invites us to embrace the unknown, to find beauty in complexity, like intricate lace woven from starlight, and to recognize our intrinsic connection to all that is. Perhaps the